Okay, today is January 23rd, 2012. Chapter 6 test. We're going to start with question number 6. We're going to jump ahead. Okay, question number 6, they've given you a table.
Take that question book.
This table shows that the number of virus particles in a cell several hours after infection. Okay, it says that the variable x represents time. So we know x is our time. And y represents the number of virus particles. How long does it take for the number of virus particles in the cell to double? Okay? So what I'm going to do is I'm going to start with the number 24. Okay? We can choose any number for this question. What is double of 24? 48. Multiply by 2, and we get 48. So they want to know, this will be our starting point. At the time of 1 hour, we're at 24 particles. Okay? We need to know when we get to 48. Now, when we go through this, is there exactly a number 48 anywhere? No. So we know it's not going to be exactly 1 hour, 2 hours, 3 hours. We're going to have to estimate, and that's why in the multiple choice, they've given you a range. Okay? Now, if we take a look, 1 hour, we're at 33 particles. Okay? So this is 1 hour away from our starting point. After 2 hours, we're at 47 particles. So we're almost there, but not quite. After 3, we're at 65. So our number 48, Jordan, our number 48 falls between 3 and 4 hours. But remember, we started at 1 hour for this question. Okay? So 1 hour, this is where it falls between these two numbers here. 1 hour is 1, 2. So it's a little more than 2, but definitely less than 3. So in terms of choosing our multiple choice, between 4 and 5 hours, nope. Between 3 and 4, nope. Between 2 and 3. This is what we're looking for. Okay? It took between 2 and 3 hours. All right, we're going to go to number 1. Number 1 says a shoe store uses the formula S is equal to 1.18F minus 2 to model the relationship between a man's shoe size, which is S, and his foot length, which is F in centimeters. Jonathan wears 9.5 shoe, or a size 9.5. Use the formula to estimate his foot length to the nearest centimeter. All right, we're going to do this on another blank page here. So the formula they gave us was S is equal to 1.18 F minus 22. Now we're going to define the two variables. S was shoe size, and F was foot size. It says that Jonathan wore a size 9.5. So is that referring to his shoe size or his foot size? Shoe size. So, in other words, our S variable is the number 9.5, which means in this formula we're going to replace S with the number 9.5, and then we're going to isolate for the F variable. Okay? So, we have 9.5 is equal to 1.18 F minus 22. Now remember, our goal here is to isolate F, so we're going to use like a reverse bedmass. We want to move things away from the side that our variable's on. So what's the first thing I want to move over? There's a hint on the board. Yes, negative 22. We want to move negative 22 to the other side of the equation. So when we move negative 22 to the other side, what do we get? Positive 22. So we have 9.5 plus 22 is equal to 1.18 times F. This will give us 31.5 is equal to 1.18 F. Now we have to isolate F. I still have to move that 1.18. That number is divided, added, subtracted from F. How do we move it? We divide it. Okay? Because it's multiplied by F, We're going to divide both sides of the equation by 1.18, which means these two will cancel out. We'll get f is equal to, and we'll bring up our calculator. What I'm going to do. Okay, so in order to figure this out, we take 31.5, and we're going to divide it by 1.18 equals 26.69. 26.69 as our foot size. So when we go back to our multiple choice question, we take a look at our options. What is 26.69 centimeters closest to here? 27. D. So our answer to number 1 should have been D. Okay, so question number 2, we brought up some formulas to look at on the side. It says, question number 2, which expression is equivalent to 5 over 8? So we're going to go back to our next page again. We're going to work on number 2 here. Okay. Number 2, what is equal to 5? No, that's not what it is. Sorry, 8 to the power of 5 over 8. I read that wrong. So 8 to the power of 5 over 3. I'm really having trouble saying words. Okay, so we're looking for the equivalent of this number. Now, if you take a look at it, they've represented it several different ways. So we're going to go through them until we get to one that we think is equal to it. So the very first one gives us 8 to the power of 3 times the power of 5th. So let's go to the very first example. 8 to the power of 3. Example 1 says 8 to the power of 3 times the power of 1/5. According to our rules, okay, this is a power of a power. Okay, so we're going to be multiplying the two exponents by each other. So this means we get 8 and we get 3 times 1/5. Does anyone remember multiplying fractions? How can I make 3 a fraction? 3 over 1. Okay, so now when I multiply fractions, I do the top numbers by each other and the bottom numbers by each other. What's 3 times 1? And 5 times 1? So to the power of 3 over 5. So in this one, this is the equivalent of 8 over the power of 3 over 5. Is that what we're looking for? No. So the first one is not the right answer. This does not work for us. Second example, very similar to the first. All right, let's put that one down. Okay, second example, they've given us these numbers. Same idea, we're multiplying the exponents. We have 8 to the power of 1 over 5 times 3. Again, we need to make 3 a fraction. It becomes 3 over 1. And when we multiply across, we get to the power of 3 over 5. Is this what we're looking for? No, it's the exact same as our first answer, just written differently. So it's not A or B. The third example gives us the third root of 8 to the power of 5. Let's bring that up. So, third root of 8 to the power of 5. Now, what I'm going to do is I'm going to change this radical. Okay, remember this is our radical form here. Radical exponents. I'm going to change the radical to a power. So what that means is, this is to the power of 1. If there's no number here, we assume it's to the power of 1. So when we're switching it back and forth, bring this exactly over. Okay. When we're switching back and forth from the radical form to the exponential form, okay, what's going to happen is our A and our B look a fraction like this. So this is to the power of 1. We keep the same base, 8. I'm going to put it in brackets. It's still going to be to the power of 5. And we're going to turn this into an exponent. Now the A goes on the top, so our number 1 goes on the top of our fraction. and the b goes to the bottom of the fraction. So we get a third. So the third root of 8 is also equal to 8 to the power of 1/3. This is now a power of a power. Same idea that we were working with in the other questions, just a little different. So we have 8 to the power of 1/3 multiplied by 5. How do I make 5 a fraction? 5/1. And when we multiply fractions, top and top, bottom and bottom. 5 times 1, and 3 times 1 is 3. So we get 8 to the power of 5/3. Is that what we were looking for? Yeah. Yes, it was. So our third answer, C, would be the answer to that multiple choice question. All right, question 3 says, which is not equivalent to 64 to the power of 1/6? Okay, so we'll put what they're looking for here to start. Question 3, they want 64 to 1/6. What is not equivalent to it? We'll take our first example, which is the multiple choice A. They had 64 to the power of 1 times 1/6. So, 64 to the power of 1 times the 6th. This is a power of a power, so we're multiplying the exponents. When we go through this, we have 64. 1 times 1/6. What is 1 times 1/6 going to be? If I multiply these two numbers, 1 times anything is what? That number, not 1. So 1/6. So we have 64 to the power of a 6th. That is the equivalent of what they're looking for. So that's not the answer. Remember, this is a negative. They don't want it. They want to know what is not equal to what we had. So A does not work because it is equal to this number. The next example is the reverse. The only difference here is they have 64 to the power of a 6th times 1. It's going to be the exact same type of multiplication. 1/6 times 1. We're going to end up with 64 to the power of 1/6. Again, exactly what they asked us. It is the same as that number. So that is not what we're looking for in this question. B does not work. Oh, keep that right. Okay. Question C. 64 to the power of 1/1 to the power of 6. So, let's bring out C here. 64 to this fraction times 6. Okay. Again, power of the power, so it's the same idea. These numbers are a little different though. We're going to be multiplying fractions. So 1/1. And how do I make 6 a fraction? Yes, I put it over 1. So I have 6/1. When we multiply fractions, we do the top by each other and the bottom by each other. I end up with 6/1 or just the number 6. So this is the equivalent of 64 to the power of 6. This is not the same as 1/6. This is the reciprocal. So this would be our answer in this question. It is C. How come I didn't write C in here? Oh, it's there, that's one. Alright, C. This is C. Now, many of you may have put this. 2 to the power of 1. We're going to address that one also, okay? So the only other option there, just to make sure, 2 to the power of 1. What is that essentially equal to as a number? 2. It's just the number 2, okay? Now, 64 to the power of 1/6 is actually a radical, okay? They're asking for the 6th root of the number 64, okay? So let's actually evaluate that on the side here. We get the number 64, and we put it to, oh, I might have put this in the wrong order. Root 6. Oh, no, I didn't. And it equals 2. So what they're telling you is 64 to the power of 1/6. When we actually evaluate it, it is equal to 2. So in this question here, this would be the equivalent of that number, even though it doesn't look the same. So that wouldn't have been an answer either. When you evaluate that, you would have got the number. Okay. Question number 12. Question A. Explain why the value of 3 to the power of 1